Hi students. Now I would like to discuss about two-dimensional array with example C program. So if you see example of C program in 2D array, the best example is multiplication of two matrix. So if you see the multiplication here, I have given a C program in this. So start the C program with hash include stdio.h. Start the main program of C and execution starts from here. Take the curly brackets. First take the integers. Here in the multiplication we are using two matrix, right? So if you are using two matrix, we have to take first matrix row and column, second matrix row and columns. So these are all the dimensions of the two matrices. Now again take the integer. So here for the first matrix, which is a 10 size of row, 10 size of column, and the matrix name is A. And the second matrix is B with the size of 10 cross 10. So automatically the result is also will get the same size, which is 10 cross 10. Now come to the here the loop counters. So for here first integer, take the I as a loop counter for rows, j as a loop counter for the columns. And here we are simply taking the common row, common from first matrix and common rows from common columns from the second matrices, that we are representing with k. So I rows and j columns. So now here for the multiplication we are simply taking the common that is from first row, that is I should common, and the column should be common from the second row. Okay. Now get dimensions of the first matrix. If you see the dimensions of the first matrix, so now prompt the user to printf, enter rows and columns for the first matrix. Enter rows and columns for the first matrix. And so for that you have to scan. So these two are also the integers, row and column of the first matrix, and this ampersand is representing the memory address located for the row 1 and column 1. Similarly, get dimensions for the second matrix with the printf, enter rows and columns for the second matrix, and for that you have to scan, and these row and column is also in integers, and here go to the memory address of providing address to the R2, row 2, and also providing address to the column. Next, now if the multiplication, when the case if the multiplication is possible, you have to check it out. Okay, for that here take the if condition here, and here column 1 means from the first matrix we have taken column 1, and here it is not equal to row 2. Okay, if this is the case here, if condition, if this condition is S, so automatically what is happen, you will get the output as error, that is matrix multiplication is not possible. So the number of columns in the first matrix must be equal to the number of rows in the second matrix. Got it? So this is the thing here, and after that here, as the error code occurs, we return to 1. Okay, so here then after that close the bracket, and now enter elements of the first matrix. Okay, so now for that prompt the user to print enter elements of the first matrix. Got it? So now here if you see the for loop for the ith row and for loop for the jth column here, so I must be here, it starts from 0, and must be it is less than the row of the first matrix. Okay, and also for J, if you see, the J is nothing but jth column, and this is also, we can see the condition is it starts from 0 and must be less than C1. That is the column of the first matrix. And then here we can see I get incremented, and here also J gets incremented. Okay, finally printf and enter the A value, which is in integers, and finally we can scan this Aij with the address that is provided for Ai of ij. This is the matrix, first matrix. Okay, next go to the elements of the, similarly if you just give the elements of the second matrix and enter the elements of the second matrix, and here for second matrix, for I this is the for loop, for j this is the for loop counter, and thereby you can print I and j for the second matrix, and this is the second matrix you can display. And after that initialize the result matrix with 0. Okay, so now for the result matrix as 0, a matrix initialized to 0. So this is also for I, we can take the for loop, and for j rows we can take the for loop. Okay, and the condition here is this must be 0 to less than R1. Okay, and also here 0 columns also from 0 to column 2. And thereby we will get the result matrix I of j is equal to 0, because initially we don't know the result. That is the reason first initiate it to 0. And after that perform the matrix multiplications here, and we can see for the matrix multiplication here we can go with the row of first matrix. So this is the for loop, and here three conditions has to satisfy. One is initializing the 0, and here test condition and incrementing. Similarly for j also will do, and finally here we can come to the common dimensions, means columns of first matrix and rows of the second matrix, so that have to take as a common dimensions, and thereby the result will become a result of Ij, that is result matrix, which is we have taken assigning symbols plus and equal. So thereby that is equal to A of ij into B of kj. So thereby here we have to print the result matrix. Result matrix after multiplication, again it is having ith row and also jth column, and the result matrix will be displayed. So, and later on printf that line by line all the rows and return to 0, which indicates execution is successful. That's all. Thank you.